Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graph transformations. This is standard A.3E in the great state of Texas, and we are using item number 52 of the 2019 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. Alright, so it's kind of small on the screen, but we have this parent function. Okay, so this parent function is just going to be your basic vanilla, right? You see that it's just got a slope of 1, right? And so we've just got this f of x equals x, right? We're just moving up at a slope of 1. It's a positive slope. Right, it goes through the origin, so that's what we would call our parent function. Now we've got it. These are different child functions. We call them parent and child functions because what we're going to do is we're going to transform them. So we've got this h of x, right, equals f of x plus 3. So let me write this here. We need to find the correct representation of h of x. So negative f of x plus 3. All right, so we're going to attack this in two different stages. So what we have here is sometimes when we're dealing with a child function, we will have a different multiplier. Okay, so like this a f of x. Let's deal with that first. This multiplier will change the slope, right? Because that's where if we're going to do this mx plus b, right? That's going to be our slope. So this multiplier right here changes our slope. Okay, so if it's greater than 1, right, it becomes steeper. If it is between, between 1 and, that a is between 1 and 0, then it becomes shallower. But here's what happens when it is going to be, less than 0. Okay, it actually flips. Okay, it becomes a negative slope. And so if it's between, that 0 and 1, right, it's at negative shallow. If it is less than, that negative 1, then it's going to be that negative, and it becomes very steep. So since we just have this negative f of x, that's really just a negative 1. So it's going to live right there. It's not going to be negative shallow. It's not going to be negative steep. It's just going to be negative. Okay, so that negative 1 just flips the slope, and it just makes it go negative, right? So we can cross off f. We can cross off j, because those are still positive slopes. They're moving up. We're going to need something that moves down. So g moves down, h moves down. Now, let's deal with that plus 3. Now that we know how the slope has been affected, the plus 3, remember, this is our y-intercept. So all this does is this pushes the y-intercept up or down. Well, our y-intercept is plus 3. So what we're going to do is we're going to push this entire linear function here, we're going to push it up 3. So our y-intercept is going to move up 3. So let's take this negative slope, and we're going to move it up to right there. So really we're looking at something that's would better be drawn kind of right there. It needs to be parallel to what we drew ahead of time, but we're going to push it up there. If we wanted it to go down, right, it would be negative 3. If we had negative 3, then we're going to go down 3, and that's really what this h looks like. See, that h looks like it's a negative 3, but that's not what we're dealing with. We have a positive 3. And take a look at what we have right there on g. We've got a negative 1 slope, right? So our m equals that negative 1. We've got a positive 3 for our y-intercept, and that is the correct child function, g.